Aqua Chill Systems recently came up with a first-of-its-kind solution for Deepak Fertilisers and Petrochemicals Corporation Limited, one of the leading producers of fertilizers and industrial chemicals in India. This plant is located in Dahej, Gujarat, and produces weak nitric acid. The entire process plant has been acquired, shifted, and reinstalled by Deepak Fertilizers from a working site in the USA. However, once it was recommissioned in India, they discovered that they are not being able to realize the same capacity of production of nitric acid as that in the USA. This was impacting more in the months of summer when the ambient conditions are relatively hotter as compared to that in the USA. The process involves the compression of ambient air, which is fed to the synthesis process, where nitrogen is separated and then used in making nitric acid. Hence, the mass of air that is fed to the synthesis process is the key parameter to achieve the rated output. Aqua Chill, along with the user team, deliberated, diagnosed the problem, and arrived at a solution. It was inferred that the suction air to the compressor needs to be cooled without impacting other process parameters so that the compressor can push the required mass of air to the synthesis process. Aqua Chill came up with a unique solution for improving the productivity of the process line by cooling the suction air of the process air compressor. This cooling was to be achieved by using absorption chillers, as low-cost steam was available from the recently implemented gas recovery project. There were three critical challenges in this implementation. One was to achieve the thermal performance of cooling the ambient air to the ISO condition irrespective of season changes. This challenge was managed by selecting the cooling generation equipment and the cooling delivery equipment of appropriate sizes. It also involved selecting the right metallurgy for the ammonia environment which is present in this plant. Another challenge was to achieve fluid dynamic properties. There was this limitation of adding any pressure drop in the intake part of the process air compressor. There was also a huge risk associated with any suspended moisture particles getting carried to the compressor inlet. That would have led to a massive problem in the downside process. Immense efforts were given in doing detailed calculations and selecting the right cross-sectional area. A suitably sized heat exchanger followed by a unique combination of mist elimination and hydrophobic material filtration. The third and equally critical challenge was that the surplus steam available from the recovery project was not sufficient to address the peak cooling demand of the suction air cooling through the absorption chiller. The quantity of steam available was able to address only up to 70% of the peak cooling demand of the suction air. Here, Aqua Chill came up with this highly innovative idea of using a thermal flywheel in the system. This was done based on harnessing the benefit of substantial variation in the hourly cooling load, even in peak season. The thermal flywheel involves storing cold energy in the form of water, unlike the routine techniques of using ice phase change material. Chilled water is stored in a tank in such a way that the cold water layer remains under warm water without any physical separation. This is achieved by using the difference in the buoyancy of water at different temperatures. This has helped in reducing the size of the absorption chiller by approximately 30%, making it just right for the steam available from the recovery project. This system has further helped in reducing the energy consumption of cooling water pumps and cooling tower fans, which are of fixed consumption irrespective of the cooling demand. It has also improved the COP of the chiller, as a substantial amount of chilling is generated during night time when the condenser heat is dissipated at a much lower temperature. All these parameters are monitored, recorded by a full-fledged instrumentation and PLC system. This innovation is first of its kind in India as far as our sphere of knowledge goes. Aqua Chill also addressed another constraint at the plant, which was associated with absorber tower cooling. Earlier, the entire tower used to be cooled by cooling tower water. Now, a part of that cooling is being achieved with chilled water, thus improving the productivity of the line. The absorber tower is a 45-meter tall structure. There were challenges in selecting the right size of pumping circuit, which was done by Aqua Chill with great precision. Using the best industrial practices in design and execution, Aqua Chill has installed this unique system that has increased the compressor output by 15%, if not more. Aqua Chill continues to provide the best solutions to all its customers through its technical expertise, practical designs, and seamless execution processes. Always ready to take up new challenges, Aqua Chill works out the perfect solutions and accomplishes excellence that benefits the customers in every way. One can vouch for the fact that with Aqua Chill in charge of your project, you can always chill.